Now let's just move on further and talk about the converse of the theorem that we have done for the triangles on the same base and between the same parallel, which says that the two triangles having the same base and equal areas, they lie between the same parallels. It means that now we have to show that they are lying in between the same parallels. So let us suppose if I'm just talking about the two triangles as nothing but, let us suppose if I'm just taking this as nothing but my first triangle and I'm calling it as nothing but ABC. Let us suppose if I'm just taking it as A, B and C. Furthermore, I'm taking the other triangle as nothing but DAB. Let us suppose if I'm just taking it as nothing but DAB. I'm taking this as DAB and I'm just joining this CD. I'm just joining this CD. So let us suppose if I'm just starting with the given condition, we have a triangle ABC and a triangle ABD on the same base AB, on the same base AB. So what we have to prove over here? We have to prove over here that on the same base AB. So let us suppose if I'll say join CD. So what we have to prove? We have to prove that CD is actually parallel to AB. So let us suppose if I'm just doing a little bit of construction over here, and in the construction I'm drawing a perpendicular. Draw CF perpendicular to AB and DE perpendicular to AB. So let us suppose if I'm just drawing two perpendiculars over here. So let if this is my very first perpendicular that I'm taking and I'm calling it as nothing but F, and the other perpendicular that I am taking, so I'm drawing a perpendicular from D. So this is actually the perpendicular that I am taking. So this is the perpendicular that I am taking. So this is the perpendicular that I am taking and I'm calling it as nothing but E. I'm calling it as nothing but E. So this is the perpendicular from the D point, from the C that I have taken. Now furthermore, if I'm just starting the proof of this one, let's just start the proof of this one. So first of all, we can see over here that we have drawn the perpendiculars CF and DE on the same line, that is AB. So if we have drawn the CF and DE as a perpendicular on the same base AB, then they definitely are parallel to each other. So what we can say from here, we can say that since CF and DE are the two perpendiculars drawn on the same line, then they will be parallel to each other. It implies that CF is parallel to DE. It implies that CF is nothing but parallel to DE. So hence from here we have proved that CF is actually nothing but parallel to DE. Now let us suppose if I'm calling it as nothing but 1. Now again, in the triangle, let us suppose we are just talking about in the triangle ABC. In the triangle ABC, we can say that the area of the triangle ABC is nothing but is equal to half into base into height. And if I'm just talking about base and height, so I can take the base as nothing but AB and the height would be nothing but CF. Let us suppose if I'm taking it as nothing but 2. Now in the similarly, I'm just talking about the other triangle. Similarly, in triangle ABD, it implies area of triangle ABD should be equal to half into base into height. which should be nothing but is equal to half into base. Base is remain the same, that is half, and the height is nothing but DE. The height is nothing but DE. So the height over here is nothing but DE. So let us suppose if I'm taking it as 3. Now again it is given to us. It is given to us that the area of the triangle ABC is actually equal to the area of the triangle ABD. It is already given to us. So let us suppose if I'll also mention it over here, that it is given to us that the area of the triangle ABC is actually equal to the area of the triangle ABD. So this is actually a given statement to us. This is already given to us, that their areas are equal to each other. Now using this particular concept, what we can say further, we can say that from equation number 2 and 3, we can say that half into AB into CF should be equal to half into AB into DE. So half and half get cancelled, AB and AB get cancelled. At the end we are getting CF, which is nothing but is equal to DE. So let us suppose if I'm calling it as 4. So we can say that from equation number 1 and 4, we know that CF is equal to DE and CF is also parallel to DE. It implies one pair of the quadrilateral. One pair of the quadrilateral is parallel and equal, It implies that CDEF is a parallelogram. It is nothing but a parallelogram. So since if it is a parallelogram, if CDEF is a parallelogram, it implies that CD is also parallel to FE, because we know that the opposite sides are parallel to each other in a parallelogram. So if a CD is parallel to FE, then it implies that CD is also parallel to AB, because FE is nothing but a part of this AB. So if this CD is parallel to the part of AB, then it is also parallel to the whole portion, that is nothing but AB. So hence it implies that CD is nothing but parallel to AB, and this is exactly what we have to prove over here, that it is lying in between the same parallels. So yes, we have proved that they are lying in between the same parallels, CD and AB. So this is all about the converse of the theorem, which says that the areas of the triangles in the same base and between the same parallels are equal.